Assalamu alaikum warahmatullahi wabarakatuh. So, welcome to the lecture. So, we will continue our discussion on the system of linear equations. Okay. So, we were discussing some methods about linear equation. We have seen how to solve the linear equation by using the Cramer's rule and by using matrix inversion method. Okay. So, let us consider one equation. Okay. Let us consider one equation. X1 plus x2 plus x3 minus x4 is equal to 2. Okay, and there is one equation, another equation, x1 plus 4x2 plus x3 plus x4 is equal to 11. Okay, so this is one equation, and another equation, x1 minus x2 minus x3 plus 2x4 is equal to minus 2. Okay, let me check. Okay, fine. Now another equation is 2x1 plus x2 plus 2x3 minus 2x4. Okay, that is equal to 2. Okay, and sorry, I have made a mistake here. This is 0. So let me check the equations. X1 plus x2 plus x3 minus x4 is equal to 2. 4x1 plus 4x2 plus x3 plus x4 is equal to 11. x1 minus x2 minus x3 plus 2x4 is equal to 0. 2x1 plus x2 plus 2x3 minus 2x4 is equal to 2. So these are the equations, and these equations, the above equations, are of 4 variables. You can see they are 4 variables. Okay, so 4 variables. What are the variables? You have the variables x1, x2, x3 and x4. So I can write you this in the form of ax is equal to b. And what is my A matrix? My A matrix is 1 1 1. My A matrix, I can write it as in the form of ax is equal to b. Anyway, I am not going to give the solution. So this is an homework, and I will give you the answer. If you have any doubts, you can ask me in the next class. Okay, so I will discuss with you. So you have x1, x2, x3 and x4, and you will get the answers as x1 is equal to 1, x2 is equal to 2, and x3 is equal to minus 1, x4 is equal to 0. So these are the answers. Okay, this is the answers. So you have to solve these equations, these equations by using Gaussian elimination method. Okay, Gaussian elimination method. Okay, Gaussian elimination method. So this is an homework for. Okay, so for a practice, you can do this problem and discuss with me in the next class. Okay, so I hope that all of you will be doing this problem. Okay, if you have any doubts regarding this, you can ask me. Okay, so okay, let's see. So you know what is the idea of pivoting, and you can use it in rearranging the equations, and you can solve this equation. Okay, so by using the Gaussian elimination method, you can solve this equation. Okay, you can solve this equation. So you see here, in the last lecture I have given you a system of equation of 3 variables x1, x, y and z. Okay, and this is an equation. Now for the homework problem, I have given you another equation of 4 variables. You know what is the method I have used in this problem, which I have solved in the last class. Okay, Gaussian elimination method. So you can use the same set of procedures according to your logic. So I will give you some more idea. What I told you is that if you get an equation ax is equal to b, and you have an A matrix, for example, you have a11, a12, a13, and in this case you will get an a14 also, a21, a22, a23 and a24, a31, a32, a33, a34 and a41, A42, A43 and A44. And what I want to tell you is that you can you have something like B matrix, like let's say it's B1, B2, B3 and B4. Okay, you have B1, B2, B3 and B4. Now what you want to do, at first you want to make this guy 0. First make this guy 0, after that make this 0, make this 0, after that you make this 0, make this 0. Okay, and you can proceed like this. So you can basically you can make this 0, then you can make this 0. Okay, or you can make okay, as a fourth step you can consider this 0 0 0, then this 5, this also 0, make this 0. Okay, so you will be getting everything 0. So then this will be sorry, this don't make this 0. Okay, don't make this 1 0, sorry for that. So you have the procedure like this. So this is A33. So you will be having diagonal elements now. Okay, you will be having diagonal elements, and finally you will be getting one equation which will be something like A44, right? Something like A44 tilde. That maybe it will be changing according to the row operations. So do the row operations, do row operations. Okay, do row operations. That means you are playing with the equations. Okay, you are adding the equation, subtracting the equation. It is equivalent to the row operations, and obtain the solution, and obtain the solution. Okay, if you have any doubt you can ask me in the next lecture. Okay, but please see the procedure. Okay, so you have to practice some problems. Without that it is difficult. If you have any doubts I can discuss you more about this. Okay, now we will see one example problem again for the Gaussian elimination method. So before that we will again see some equation of 3 variables. I told you what do you mean by the equations of 2 variables. For example, you have an equation for 2 variable, for example, then you can write like this: A11, A12, A21, A22. This is the A matrix. You have 2 variables, x1 and x2, which is equal to some b1 and b2, right? This is the 2 variable equation. Next is the 3 variable equation. Okay, 3 variable equation: A11, A12, A21. Sorry, A11, A12, A13, A21, A22 and A23, A31, A32 and A33. Then I told you this into, let's say, x1, x2 and x3, which is equal to b1, b2 and b3. This is our equation. So this is an equation of 3 variables, and I told you if you are considering x1 and x2, you will be getting 2 lines. Okay, so this may be the equation 1. For example, this will be the equation 1 and this will be your equation 2. Okay, so this cannot be written like this. Okay, sorry, I will rewrite it. So A11, A12, A21, A22, then x1, x2, which is equal to b1, b2. So this the first row is actually representing the equation 1, and the second row is representing the equation 2. So there are 2 equations basically. You will be having one equation, let's say the first equation was like this, and the second equation I will show using another color, will be like this, and the solution of this is the meeting point. So you will be getting some x1 star, you will be getting some value of x1 star and x2 star. Okay, x1 star and x2 star, which is the solution actually basically. Okay, so this is the equation of straight lines, basically equations of straight lines. Okay, so that we will see here. Okay, you can see I have already told you regarding this. These are all the equations of straight lines. I have already told you about this. So you can see here that these equations are having the solution here. You see here there is the solution. Now we will see another here. This is the equations of three variables. The second case is the equations of three variables. So there are equations, three equations basically, 1, 2 and 3. So three variables are there. You can see the first variable is x1, x2 and x3, and these equations, actually you need a three-dimensional plot for this. It will be the equations of planes, okay, like this. So the meeting point of these planes will be the solution. Here the meeting points, the above case, actually the meeting points of line is the solution, and here the meeting points of planes will be the solution, okay. So you see here I have equation x minus y plus 3z. You can see here on the left side top, x minus y plus 3z equal to 5. Equation 2, I have 4x plus 2y minus z equal to 0. And the third equation, which is shown with the blue color, first equation was shown, you can see it's a light, some light blue color, or we can say it's light green colors. Now second equation is a light red color. You can see it's 4x plus 2y minus z equal to 0. And third equation is x plus y plus z equal to 0. You see here it is not these equations are not straight lines, but they are planes. You can see they are planes, surfaces, planes. And the meeting point of these planes, you can see here that the meeting point of these planes, actually basically it is the solution, okay. And I will show you next example. You see here, this is also the same thing. The meeting points of the planes will give you the solution. Now you see here that these equations are little bit different, and these equations you see on the right hand side, b1, b2, b3, all these are 0. So right hand side is equal to 0. That means all these planes will be passing through 0, 0, 0, the point 0, 0, 0. You can see at the center of this. So that obviously one solution for this will be 0, 0, 0. So 0, 0, 0 will be satisfying all the equation. That means x, y and z all become 0 is a solution, okay. So I will be giving you another example. You see here again all these are passing through the origin. That means that if you see equation 1, 2 and 3, the right hand side of all these equations are 0. So you can see here that the solution, the meeting point of all this plane is at 0, 0, 0. So these are nothing but the homogeneous equation, okay. But if there are only two variables, just x and y, you can see here that it is the equation of straight line. But here you see here it is the equations of planes. But since this is homogeneous, it is passing through the origin. So we will see the animation. You can see here the video that this is the equation. Here it is not 0. So this is the equation that I think we have solved in the class. I think so. We have solved in the class. No, this is not solved in the class, I think. Okay, this is a different example. Anyway, so this is the equation 1, 2 and 3. Here b1, b2 and b3 are not 0. So you see here that the equations are not passing through the origin. So basically they are not passing through the origin. I hope this part is clear to you, right? And next is, again all these equations are passing through the origin, okay. So this obviously the solution for this will be at the origin. So these are the homogeneous equations. So if the equations are not homogeneous, it will not be passing through the origin. So you see here that it is not passing through the origin, and the solution is somewhere outside the origin. Now but here you see here, obviously the solution it is at 0, 0, 0. So you can see that all the planes are meeting at some point, and that point is 0, 0, 0. It's clear, okay. But here all the planes are meeting at some other point which is not 0, 0, 0. So you will be getting some values for x, y and z which is not 0, okay. It can be one of the variable can be 0 also, there is no issue. But here you see all the right hand side is not 0, that's why, okay. So this you should understand that and all the equations, so these are all showing the planes, okay. And all the equations which are not all the equations which are 2 variables are showing the straight line, and the 4 variables means it's difficult to draw. It's a 4th dimension is also there, so it's difficult to draw, but you can imagine it's a hyperplane. We will be calling it as hyperplane. Okay, so we will be doing one problem again for the Gaussian elimination method. One more example. So example, solve by using Gaussian elimination method. Okay, so solve by using Gaussian elimination method. Okay, Gaussian elimination method. So let us consider the equations. Okay, solve the set of equations by using Gaussian elimination method. So 2x1 minus x2 plus 5x3 is equal to 10. So this is one equation. This is one equation. So next is x1 plus x2 minus 3x3 is equal to minus 2. Another equation is 2x1 plus 4x2 plus x3 is equal to 1. Okay, so there are equations like this. Now we want to find solve by using the Gaussian elimination method and obtain x1, x2 and x3. So this is the question. So you have to find all these things. So we will be writing the augmented matrix. So we will be writing the answer, augmented matrix. So which equation I will consider first? That is the main question here. You see here, I can consider this equation or this equation because both are having 2x1, right? So but anyway, I will be considering this equation for this example now. Next, I can consider, okay, I can consider the equation number 2, or I can consider the equation number 3. Okay, so now why I can consider like that? It can be considered because you see here, this in both cases the pivoting is possible. That's why. So let us augmented matrix. Okay, augmented matrix. Sorry, augmented matrix is equal to, okay, augmented matrix. I will write first be 10 minus 2 and 1, and this is 2 minus 1 and 5. This is 1 1 and minus 3. This is 2 4 and 1. Okay, so this is my augmented matrix. Now I am doing some operations on the augmented matrix. So first step, okay, step 1, let's say step 1, I am doing the operation. So what I want to do, I want to I want to make this guy 0, right? I want to make this guy 0 then. So before that, you see here, this number is 1, this number is 1. So what I want to do, I will multiply the row 2 with the 2, then it becomes 2. After that, I can subtract row 2 from row 1, or row 1 from row 2. So I will going to do the operation. You see, I am doing, this is 2 minus 1 and 5, and this is 10. Now I will multiply my row 2 as row 2 multiplied with 2. Okay, I will multiply with 2. So it become 2 and minus 6, and this minus 2 become minus 4. Okay, now this is 2 4 and 1. I think yeah, this is finished. Now this is, now after that I will be changing again this guy. I will be changing into, this is my step 3. I will use another color. Step 3, I will do some operation. What is my operation? I will change my row 3 as row 3 minus row 2. Okay, I think I have no space here. Row 3 I will change as row 3 minus row 2. Okay, and row 2 I will change as row 2 minus row 1. Okay, row 2 minus row 1. Row 2 I will change as row 2 minus row 1. Okay, so there won't be other changes. So anyway, I will write here 2 minus 1, 5. Okay, then this is 10. Now what I am going to do, I am going to change the row 2 because I want to make this part, I want to make here 0. I told you we want something here, some elements it's not possible, there is no issue here, but I want here 0, 0, 0. This is lazim. Okay, it's that means I need this always in Gaussian elimination method. So I want to make this guy 0, then this one and this one. Okay, so that is the procedure 1, 2 and 3. So for that I am using some procedure. So that's why here you see here this element is 2 and this element is 2. So I can change my row 2 as row 2 minus row 1. So 2 minus 2, that means 0. 2 minus minus 1, you see here this is 2 and this is minus 1, and so 2 minus minus 1 is 3, I think so, right? It's 3. Then next minus 6 minus 5, that become minus 11. Okay, then minus 4 minus 10 become minus 14. Okay, so that's fine. So this operation, khalas, this is finished. Now next is 2 minus, next I can make this as 0. So for that, so this we have made 0, next we are making this 0. So you can use row 3 minus row 2. So 2 minus 2, that becomes 0. Next is 4. 4 minus minus 1, that become how much? 4 minus minus 1, I think so. Row 3 minus row 2, sorry, I want row 3 minus row 2, not row 3 minus row 1. So sorry for this. Okay, so I am using row 3 minus row 2. Okay, I can use row 3 minus row 1 also, there is no issue, but here I have already written row 3 minus row 2. So this is 2, so this is 2, so 2 minus row 2, what is row 2? 2 minus 2, it is 0. Then 4 minus 2, it is 2. Okay, 4 minus 2 is 2. 1 minus minus 6, that means 7. Okay, and this become 1 minus minus 4, 1 minus minus 4, this become 5. Okay, so I am going to rewrite it in the next page. So that is I will get this is 14, yeah, I will get this as 2 minus 1, 5, and this is 10, no change. Now this becomes 0, 3 minus 11 and minus 14, and this has become 0, 2, 7 and 5, right? Now I am going to do some other operation. What is my operation? I am going to change my row 3 because I want to make this as 0. You see here, this I want to make as 0. Now for that I am going to change this. Okay, so I want to make this as 0. So for that I am going to change this. So first of all, I will be doing one operation on this. Row 3 I will be changing as row 3 will be multiplied with 3. So 3 times row 3. So if I multiply with 3 times, so you see here it's become 0, this becomes 6, okay, and this become 21, and this become 15, and there are no other changes. So 0, 3, minus 11 and minus 14, this is 2, minus 1, 5 and 10. Okay, there is no other issue. Now after that I am going to change this another step. This is step I think step 4. Okay, why I am doing, you see here this is 6 and this is 3, so I can do something, right? I can play with row number 2. So I am going to do some operation with the row number 2. So you see here, if I multiply my row number 2, if I multiply, I am going to change my R3. If I am subtracting, that means R3 minus 2 times R2. What will happen? You see, R3 minus 2 times R2, what will happen? So I will change it here itself, you can see. Okay, I am going to change here itself. That means R3 minus 2 times R2, what will happen? I am multiplying this guy with 2 and subtracting from R3. So R3 I will be changing R3. So this is 2, this is minus 1, this is 5. So the same color, 2, minus 1 and 5, and this is 10, and there is no change here, 0, 3, minus 11 and minus 14. But this guy I will be changing. So 0 minus 2 times 0. So 0 minus 2 times 0. So it will be, I am going to change this. Okay, I am going to change this. I will use another color. I am going to change this. You see, 0 minus 2 times 0 is 0. 6 minus 2 times 3. So 6 minus 2 times 3, it is nothing but 6 minus 6, which is equal to 0, right? So we got here 0, we got here 0, and we got here 0. Now it's 21 minus 2 times 21 minus 2 into minus 11, which is equal to 21 minus, that means 2 into 11 is 22. So 21 plus 22, that's 43. So you will get 43 here, okay, right? And this is 15. Next you will talk about this one. So this is nothing but 15. You can see here, this is 15 minus 14. Not minus 14. This is 15 minus 2 into minus 14, right? So this is nothing but 15 minus, that means plus 28, which is nothing but the 43, right? Again 43. So I will get here 43. Now you got this equation in another way. That means you got all these lower triangular elements all become 0. So this is the idea in Gauss elimination method. So we will make a lower we will make all the lower triangular part as 0, lower part of the diagonal, everything becomes 0. So I will write this equation again. So this is 2, minus 1, 5, 10, 0, 3, minus 11, minus 14, next 0, 0, 43, 43, okay, right? Now this equation, I will take this equation, last equation, to solve, because we got the final point. That means it is 43z is equal to 43, right? So this is it x, y, z? No, it's x1, x2, x3. So 43 x3, because this is the coefficient for x1, this is the coefficient for x2, and this is the coefficient for x3, and this is nothing but b3, your new b3 tilde. I will tell b3 tilde. So 43 x3 is equal to 43. So what is x3? 43 by 43, which is equal to 1. So you got it. Now use this second equation. So it is nothing but 3 times x2 minus 11 times x3 is equal to minus 14. So 3 times x2 is equal to minus 14 plus 11 times x3, which is equal to minus 14 plus 11 times, you know what is x3, I will put it here. X3 is 1, so which is equal to minus 14 plus 11, which is equal to minus 3. So what is x2? x2 is equal to minus 3 divided by 3, okay, because 3x2 is equal to minus 3. So this is equal to minus 1, right? This is equal to minus 1. I hope this is clear. Now you can use the other equation, so I will write it here itself. I can use another equation, last equation. So what is that? 2x1 minus x2 plus 5x3 is equal to 10. So what is 2x1? I want x1. It's 10 plus x2 minus x3. That means I am moving everything to the right side. Okay, that's why the sign is changing. So this is nothing but 10 plus, what is x2? x2 is minus 1, minus 5 into, what is x3? x3 is plus 1, so that's it. So 10 minus 1 minus 5. What is that? The answer. So this is 2x1. 2x1 is equal to 10 minus 6, which is 4. So what is x1? x1 is equal to 4 by 2, which is equal to 2. So you got the answers. So all the answers we got. So what is the answers? I will write the answers here. Our answers are x1, x2 and x3. What is x1? x1 I got it, which is 2. And what is my x2? My x2 is equal to minus 1. What is my x3? Yes, x3 is equal to 1. Okay, so this is my answer. So I hope this problem is clear to you. So we have seen 2 examples again. So you will see more examples in the tutorial, and I have given you one homework. So if you do all these things, it will be fine. Okay, so you will understand the concept. So this is the Gaussian elimination method. So we have another technique which is known as the Gauss-Jordan method. Okay, so Gauss-Jordan method is almost similar to Gaussian elimination method, but there are some differences anyway. So we will talk about now Gauss-Jordan method. Okay, so this is also used for obtaining the solution to set of linear equations. Okay, linear equations. So all this can be programmed in the MATLAB. Inshallah, we will see that later. So all this can be programmed. Now obtaining the solution to set of linear equations. Okay, that is the idea of using the Gauss-Jordan method. And you know that any equations can be written as Ix is equal to B. And what I am going to do is that I will be making an augmented matrix as same like A and B. This was the method I have used in the Gauss elimination. But you know that, for example, if I consider an equation, I will be considering an equation a11 into x1 plus a12 into x2 plus a13 into x3 is equal to b1. Okay, a21 into x1 plus a22 into x2 plus a23 into x3 is equal to b2. a31 into x1 plus a32 into x2 plus a33 into x3 is equal to b3. Okay, now we have this one. Okay, now we can write it in the matrix form: a11, a12, a13, a21, a22, a23. So a31, a32, a33. Now into x1, x2 and x3, which is nothing but b1, b2 and b3. This is our equation. Now we will arrange as we have seen. So we will first arrange the equations, according to the pivoting position. So first this should be high. In the second equation this should be high, and the third equation this should be high. So in that manner actually we will be arranging the equations. Okay, we will be arranging the equation. That means we will do the pivoting here also. Okay, no issue. If you do the pivoting, that will be good. Now you see here that this equation is giving you A, and this is X, and this is your B, right? Now I can write the augmented matrix as A11, A12, A13, A21, A22, A23, A31, A32, A33, and I will write the augmented matrix, okay, like this. This is B1, this is B2, and this is B3. And the third procedure, convert this part. That means this is A and this is your B. Convert your A to I. That's it. You will convert your A to I. That means in this case, you will convert your matrix A by using row operation. You can use row operation to convert A to 1 0 0 0 1 0 0 0 1. So automatically, if you do the operation, your B will be changing to something like B1 tilde, B2 tilde, and B3 tilde, right? So now this equation you can read like this. Equation you can read like this is like x1 is equal to b1 tilde, because 1 into x1 plus 0 into x2 plus 0 into x3. So that means it is 1 into x1. Next, this second equation will give you x2 is equal to b2 tilde, and third equation x3 will give you b3 tilde. So this is your solution. So this is your solution. So we will see a problem. So in this case, you have the procedure. You will first make this guy, you will make 0. You will make this 0. You will make then this one 0. Then next you will make this guy 0. Next you can make this guy 0. Okay. So if this becomes 0, then you can use the row 3 to make this 0. Make this 0. So you can use this step 4. This is 5. Okay. Next you can use this also 0. Okay. According to your logic, you can proceed. But start from on the left side. That means second row left side. 1, 2, and 3 procedures. Very important. Okay. So now we will see a problem. We will see a problem by using Gauss-Jordan method. Okay. This problem, this is an example. X minus 2y is equal to 4 minus 4 minus 5y plus z equal to minus 9. 4x minus 3z is equal to minus 10. So solve using Gauss-Jordan method. Okay. That means you have to find what is x, y, and z. That's it. Okay. You have to find x, y, and z. Okay. Now, so if you have any doubts, you can stop in between, and I will answer you. Okay. I will give you another explanation, also another kind of explanation also. So I am going to write all these things in a matrix form first. Okay. You see here in the first equation, I am going to write this is x, y, and z, and this is minus 4, this is minus 9. So I am going to write the answer minus 9 and minus 10. Okay. I hope this is clear. Next, you see there is coefficient for x, so the coefficient for x is 1, and there is no there is coefficient for y also, minus 2, then it is 0. There is no coefficient for z here in the first equation. Now in the second equation there is no x, so the coefficient for x is 0, and for y it is minus 5, and for z it is 1. And here the coefficient for x is 4. Next, there is no coefficient for y, so it's 0, it's minus 3 then. Okay, that's it. So I will now write the augmented matrix. Augmented matrix, I will write it as 1, minus 2, 0, 0, minus 5, 1, and 4, 0, minus 3. Next, I will write minus 4, minus 9 and minus 10. I hope this is clear how to write the augmented matrix. Now, we will do some operations. So, as I want to make, you see here in this, it's very easy. This is already 0. So, already 0. Already 0. Now, we will make this guy 0. That's it. So, for this guy to make a 0, I will try make use of row 1 basically. So, I am going to write, okay. So, I want to make this guy 0. So, I am going to rewrite first all the equations. So, and I will make row 3, I will change row 3 as row 3 is nothing but row 3 minus 4 times row 1. Okay, I will make like this. All other will be same. So, this become 1 minus 2, 0, no change. Okay, then 0, minus 5, 1 and minus 9, there is no change. But here you see here, I will multiply, this is 4, 4 minus, you see here first one, it's 4 minus, if I take this guy, 4 minus, I will take the row 1, okay, 4 minus 1 into 4 minus, what is that our, sorry, what was our conversion? Yeah, it's R3 minus 4R1. So, 4 minus 4 into 1, that is equal to 0, right? We made it 0. Next, this is 0. So, 0 minus 4 into minus 2. It's minus 8, that means plus 8, right? So, you get it, you got it, this is 8. Next, you take this guy. So, minus 3 minus 4 into this is 0. So, 0. So, minus 3. Right, again minus 3. Next, this is minus 10 minus 4 into minus 4, that is minus 10 plus 16, that will be 6. Okay, so this will be 6. So, you got it. Now, you see here that I need, what kind of matrix I need according to Gauss-Jordan method? According to Gauss-Jordan method, I want identity matrix. So, I will just write an identity matrix on the right side here. What is my identity matrix? It's 1, 1, 1. And this 0, 0. Okay. Next, this 0, this 0, this 0. This is your B1 tilde, B2 tilde and B3 tilde. So, you see here, I want this element. Now, I got here here actually I have got minus 5, but I want here 1. So, I will multiply this row 2 with minus 1 by 5. Then it will become, because this is minus 5. So, minus 5 into minus 1 by 5, it will become 1, right? So, I will multiply row 2 with minus 5. So, you can do any procedure whatever you like, which is convenient for you. Okay, 1 minus 2, 0, minus 4. Then I will change my row 2 as row 2. I will multiply with minus 1 by 5. So, if I multiply with 0, there is no change. But minus 1 by 5 into minus 5, it become 1. And this become minus 1 by 5, right? And this become 9 in minus 9 into minus 1 by 5, it become 9 by 5. Okay, and here there is no change. I am not going to change anything. 0, 8, minus 3 and 6. So, I have changed only here. Okay, I have changed only here. Okay, this one. Now, again, so this is my let's say, okay, this is my step 1. So, this is my step 2 and this is my step 3. Now, step 4, I will write it here itself. So, I have a matrix now, step 4. Okay, I am going to change my yeah, you see here this is 1, 1, but this guy is not 0. I am going to change my row 3 as row 3 minus 8 times R2. You see here this is 1. So, if I multiply this 1 with 8 and I subtract my row 3, 8 minus 8 times R2, what will change? The row 3 will be changing. So row 3 will be changing. So how it will be changing? So 0 minus, you see here, it's better I will use the next page. So I will write it again in the next page. I will write it again in the next page. So let me look at a glance anyway. Yeah, I will rewrite it again. 1 minus 2, 0, 0, 1 minus 1 by 5, 0, 8 minus 3, minus 4, 9 by 5, and 6. This was my matrix, augmented matrix. Okay. Now I am going to change here this augmented matrix to something like this. R3, I am going to change R3 R3 become R3 minus 8 times R2, right? And so this become, you see here, 0 minus, so I will write the steps here itself. 0 minus 0 into 0. Okay, 0 minus 8 times 0. So this become 0. Now, so this is finished. Next, this one, this is 8 minus, what is this? 1. So 8 into 1. So this becomes 0. No issue. Okay, we got it. We got 0. Next, we will talk about this one. Okay, so minus 3 minus 8 into minus 1 by 5. So this become minus 3 plus 8 by 5, right? So how much it become? So minus 15 plus 8 by 5. So this become minus 7 by 5. So this become minus 7 by 5. And you can do the same operation here also. For this element, you will get minus 42 by 5. So you got it. So you have changed this and rewritten. Next, you can change the row 1, because for the row 1, I think yeah, for the row 1 there is a problem. You see here, for the row 1 there is an issue. Let me check here. Okay, row 1 there is an issue. Yes, so row 1 I am going to change. Row 1 I am going to change. For row 1 there is a minus 2 here. I don't want it. Actually, I want to make it 0. So row 1 I will be making it 0. So row 1, what it is, I am going to change row 1 as row 1 plus 2 times row 2. Okay, so what it will be? So first one, you see here, this is the element. So 1 plus 2 times 0, that is 0, no change. So it will become 1 times 2 times this 1 itself. Next, next is, you see, minus 2. Minus 2 plus 2 times 1, that becomes 0. Got it. Next is 0 plus 2 times minus 1 by 5. It's become minus 2 by 5. So this become minus 2 by 5. So we will again remove it later. And next is minus 4. Minus 4 plus 2 into minus 1 by 5. So this become minus 4 minus 2 by 5. So this become how much? Minus 20 minus 2 by 5. Okay, so minus 20, let me check here, minus 2 by 5. So this become minus 4 plus 2 by 5. So how much it will be? It will be minus 2 by 5 again. Let me, okay, sorry. So this is 0 and minus 1 by 5. So plus 2, okay, plus, actually it is plus. So it's become 0 plus, okay, let me check, it's minus 4, okay, minus 4. So we will talk about minus 4 now. So minus 4 and this is 9 by 5. I have made a mistake here. 9 by 5. So 2 into 9 by 5. So this become minus 4 plus 18 by 5. Okay. So this is become minus 20 plus 18 by 5. This become minus 2 by 5. So we will get again minus 2 by 5 here. Okay. Minus 2. And there is no change here for this row. There is no change. No change. Okay. No change. This become 0, 1, minus 1 by 5 and 9 by 5. So I will rewrite again. I am going to rewrite again this thing because there is no space there. Rewrite. I will repeat. Okay, this is repetition. I will repeat here. So this become 1, 0, minus 2 by 5 and minus 2 by 5. 0, 1, minus 1 by 5 and 9 by 5. 0, 0, minus 7 by 5 and 42 by 5. Minus 42 by 5. Now, that's it. Okay. So minus 42 by 5. Now you see here, I want this element as 1. So what I want to do, I will multiply my row 3. So I am going to change this. I will multiply my row 3 with this is minus 7 by 5. I will multiply with minus 7 by 5. So I am going to change this. So 1, 0, minus 2 by 5 and minus 2 by 5. 0, 1, minus 1 by 5 and 9 by 5. 0, 0, minus 7 by 5 and minus 42 by 5. So I am going to multiply now. I am not going to write it directly. I am going to multiply our row 3. I am going to multiply our row 3. I am going to change it with minus 5 by 7 into row 3. So if I multiply with 0, no issue. 0, again 0. So I am multiplying here now minus 7 by 5 into, no, I am multiplying here with this guy. That means minus 5 by 7 into row 3 element is minus 7 by 5, which become 1. So that's a good idea because we need 1, 1, 1, 0, 0, 0, 0, 0, 0, like this, right? So we got this one. Okay. And this become next this one, it become minus 5 by 7 into minus 42 by 5. So this will cancel. Minus minus become plus and this become 6. So you will get here 6, right? So you got it 6, but there are some issues still you have something here and there is something here. So I want to remove this all, and you can use the row 3 for removing everything. So you can use row 3 for removing, for making this 0 and also make this guy also 0. We want to make this 0. So I will rewrite it again. 1, 0, minus 2 by 5. 0, 1, minus 1 by 5. 0, 0, 1 and minus 2 by 5, 9 by 5 and 6. Okay. So I am going to change. This is rewriting. Rewrite or repeat. Okay. I am repeating from the last page. Okay. Now I am going to do something. I am going to do some operations. Okay. I am going to change my row 1 like this. Row 1 become R1 plus 2 by 5 into R3, because you see this guy is 2 by 5, right? It's 2 by 5 into R3. So row 1 become row 1 plus 2 by 5 into R3, because if I add 2 by 5 and multiply with R3, R3 is always 1 here. So there is no change for R3. I can rewrite it again. Same. Okay. Now this become 0, 1 plus 0 times R3. That means you see here, okay, I will use another color. So I am using for R1. So you see here, it's become 1 plus 2 by 5 into R3. This become again 1, no change. right? Next, 0 plus 2 by 5 into R3. This is R3 anyway, so it become 0. So this become again 0, no change. But this guy and this guy will take, okay? So this become minus 2 by 5 plus 2 by 5 into, what is the R3 element? It is 1. So this become minus 2 by 5 plus 2 by 5. This becomes 0. So minus and plus, it will cancel and 0. Now the last one, see this one and this one. So we will take minus 2 by 5 plus 2 by 5 into, this guy is 6. So this is 6. So 6, okay? 2 by 5 into 6. So what it will be? You will be getting it as 2 by 5 into 6. So how much? So this you will be getting as minus 2 plus 12 divided by 5, okay? So this become 10 by 5, which is equal to 2. So you will be getting here as 2, right? You will be getting it as 2. Next we will consider the change here, the transformation here, this guy, R3. And what is the transformation for R2? Sorry, not R3, R2. R2 become, R2 is changed to R2 plus 1 by 5 into R3. Why I am using like this? Because there is a minus 1 by 5. So if I add like this, then I can cancel. Now I will take this element, R2 0 plus 1 by 5 into 0. So 1 by 5 into 0, this becomes 0. So no issue. Next, this one, 1. 1 plus 1 by 5 into 0. Again this is 0, right? So this becomes 0. Now 0. Now next one, okay, this one, minus 1 by 5 plus 1 by 5 into 1, right? This is 1. So this become 0 again. So you got it 0. And sorry, this is 1 plus, sorry, this is 0. This is 1 actually. So this is 1 actually. You see here, this is 1 plus 1 by 5 into 0. That means 1 plus 1 by 5 into 0 is 1. So that's why I have made a mistake here, okay? So it's 1. Next, okay, next is 9 by 5, right? So we have 9 by 5 plus 1 by 5 into 1 by 5 into 6. So you will get it as 9 plus 6 is 15 by 5, which is equal to 3, right? You will get it as 3. Okay, now I will rewrite this again. I will rewrite this guy again, okay? So I am going to rewrite. What is that? This has become 1 0 0 0 1 0 0 0 1. We got this. Now on the right hand side, what is that? 2 3 6, okay, 2 3 and 6. So we got the answer. You see here, this is for the coefficient x, and this is for the y, and this is for the z. So if I take the first equation, you see it's nothing but x plus 0 equal to 2. That means that your x is equal to 2. Similarly, this become, if you take the second equation, 0 plus y plus 0 is equal to 3. That means that your y equal to 3. If you take the third equation, 0 plus z is equal to 6. That means that your z is equal to 6. So you got the solution. So this is giving you the solution. So this is nothing but the solution directly. You don't need to solve it again. So what is the solution? Your solution is x is equal to 2, y equal to 3, and z equal to 6. So this is the solution to this equation. So if you put these values in any of the equations that is given in the question, you will get exactly the numbers on the right side. And these are all not homogeneous equations, okay? If it is homogeneous equation, definitely the solution will be 0 0 0, and all the right side will be 0. but here it is, the right sides are not 0, so it is not homogeneous anyway. So I hope Gauss-Jordan method is very clear to you. If you have any doubt, we can discuss in the next class. Okay, thank you.